Hey folks, tidying up the Driveshafts videos. Didn't realize the video I did make was during COVID and it was just a test review. So Driveshafts, drive axles is what this is. Front wheel drive and rear wheel drive. That's what those two acronyms stand for. So eye injuries, just make a note there. It is probably the section where I've seen the most injuries at work. And that's to do with you're dealing with bearings, very similar to wheel bearings, but they're a sintered steel, and they can, if you're hitting them with hammers, pieces can fly off. So just, again, it should be a habit to wear that. The other one is, if it doesn't feel right, it probably isn't. So that's mostly just a caution when you're doing U-joints. And we've all made mistakes. Every mechanic, I think, out there, if they've done enough of them, has made mistakes putting in new U-joints or taking out even. The other thing is all retainers need to be functional and installed. So that's not a lot different than other automotive parts. Just this one and how fast the drive shaft spins, it's hugely can go bad if you happen to not have a retainer fully seated or it's not on at all. And we'll get into what those retainers are as we move through. So never use impact. So technically you're not supposed to use impact on anything on a car, but and they say for the axle nuts especially so, because it can hurt the bearings, that hammering. However, you're never probably going to see this applied in the mechanics world. So just a note, it is a question that was asked in tests, like trades tests. I'm not sure that's the reason it's there, why it's mentioned. And this was one, do not push a front wheel drive around when the axle shaft is removed. At least have a dummy shaft to put in or a dummy bolt and nut. And the reason is the wheel bearings, the way they're made, it's a double ball bearing. So it's not like our tapered roller bearings we did. That as you push and turn, especially heavier vehicles, they'll tend to pull the stub shaft out, and then the wheel bearing will fly apart. Not fly apart, but come apart. It's not like and it just takes pushing a front wheel drive for that to happen. So basically, through the slideshow, I want you to be able to, like any other section, identify the function of the driveline components, then know the function and identify service and repair drive shafts, U-joints, and CV joints. We won't get much into U-joints, but we will see videos on that and or other. Diagnose and repair driveline vibrations. So similar to wheel balance. So basically the function of the driveline as a whole is to transfer torque from one component to another. So from the transmission basically to the wheels, and depending if it's a front wheel drive or a rear wheel drive or how that configuration is, depends on the components it'll have. So the upper one is more or less a front wheel drive setup with half shaft axles or axle shafts. And the bottom one here, my arrow that's the drive shaft. So these are called drive shafts. These are sometimes called drive shafts, as you see here, but they're more of an axle than they are really a drive shaft when we compare here. So there's your drive shaft. Inside this rear end, coming off the differential, would be axles. So the differential in this part is in-house of the transaxle, and then it goes to the axles. So it's basically the output is the axles to the wheel, same here. But intermittently could be switched back and forth. So driveline parts. So depending on which one you have, if it's a drive shaft, you're going to have a slip yoke. If it's a CV axle, you're going to have a plunge joint. So both of those can accommodate for changes in length. So as our suspension moves up and down, the actual length of that shaft has to allow for some change. Universal joints can only accommodate for angle changes. So again, whenever you're hitting bumps or potholes, that rear end's going up and down, so that means that drive shaft needs to be able to change the angle that it's delivering the torque at. And then the drive shaft is a tube in between, okay, or an axle. We could say that those front shafts axles to connect the different joints together. And within that, if you've ever watched drag racing, if you've ever seen a funny car or drag race where the vehicle will roll over upon acceleration, something has happened to that vehicle for the torque reaction. And vibration control we'll speak to too. But torque reaction is to prevent the rear end from turning the vehicle over when the torque's applied to it. So slip yoke, basically right there is a drawing picture of slip yoke. So this transmission output shaft, this is your yoke, okay, or slip yoke. So what there is there's splines on both of these, so it can transfer the torque. So the splines allow the transfer of torque. And then, but the splines don't lock this shaft in place. So if we hit a bump up and down, then this can go in and out. And it's not a lot of travel that the slip yoke needs to accommodate for, but it still does need to be able to change. So we need to have space there so that when it goes up and down. Internal splines, and then there'd be external splines. So in this case, the transmission output shaft has external splines and the slip yoke has internal. And then the universal joint would hook to this, and then the drive shaft would hook to that. This here outer part, if you're asking for interest, is an inertia ring. So it's rubber with a little bit of weight. That's there for either preventing a humming or moaning noise when it's going down the road, which essentially is a vibration, but it's not vibrating the vehicle necessarily, just making a noise, or also there to prevent vibration. Okay. Actually, 3 ways here. I don't know if I say the third way, but there's 2 ways that the U-joint can be attached to and this would be called the fixed yoke at the differential. So you get the slip yoke on the other end that allows it to change in length, and this one is called the fixed yoke. They can be bolts or strapped on, or U-bolt on, but there's also a style that's flange style, and many Fords have that. So hopefully, just another version, not a big deal. Just as you see them, know how they come apart. So universal joints, as you see, I have an AKA there, also known as variable velocity joints. And there's a video that comes a little later in this that I'm not going to show, but you can get into from the folder. And it does a great description, has a great little thing to show how the velocity they will change speeds. Okay, so the U-joint's function, though, is to transfer that torque between 2 parts and not necessarily in a straight line. So that's where the universal joint allows for changes in angle. So as we look here, the transmission for the most part is fixed, but as we hit the accelerator, it will twist and torque, and it may cause it to go up and or down too. But however, it's the differential. This is shown here, but with that, there's going to be a coil spring on top of that, or a leaf spring, and that axle is going to bounce up and down based on you hitting bumps, because the wheels are on the outsides of this. So then this here fixed yoke will move up and down, so that angle will change as or if we increase the load of the vehicle, that's going to change the angle as well. Say it's a truck. And then the slip yoke again would be right in there. So notice here we got similar to our lip clearance that we talked about angles. We've got an angle there and an angle here. And those 2 angles become very important to prevent vibrations. So we need the U-joints to operate at an angle. So no angle, the needle bearings will not rotate, and they will cause a condition known as Brinelling. And they never move, they never change position. So each time you brake or come off the accelerator and accelerate, those little needles are hammering that U-joint and will cause a Brinelling. So they need to work at an angle, and that angle must be at least 1 degree. So that's not there, but maybe talked about later. The maximum angle, though, that you should be working a U-joint at is 12 degrees. So people who do lift kits, lowering kits, you need to be aware of these changes you're making such that the vehicle drives safely and it drives without excessive vibration or excessive wear on parts or strain on a part where it could eventually fail and cause catastrophic damage if the U-joint breaks or something like that. So there's what I speak to if the needle bearings don't work at an angle. That's called Brinelling. Those are the little rollers, the bearing part So this would be like an anti-friction bearing. So there would be an outer race. This would be the inner race, and then the needles in between. So you can see this one it looks a little better. I don't know if that's Brunelling or just maybe grease stains. And there is a medium of grease in there. So that would be a U-joint. Now you'd want to check that vehicle to see if the angles are set correctly, and maybe be able to prevent that from happening the next time whenever you replace that joint. Oh. So U-joint phasing is another thing that's done to prevent vibrations, but it is done in the sense that it's kind of dummy proof for us in the trade. We don't really have to worry about it because the drive shafts are built like that. And anything with a two-piece shaft will have a master spline that will line up that phasing. So, but this here graph is just showing that the U-joint does speed up and slow down. Now, what the phase does is one end of the drive shaft is speed, or one end has a U-joint, the other end has a U-joint. But because they're in phase, and I'll show you a picture in a minute, they cancel out. So when one is speeding up, the other is slowing down. So these points are those meeting speeds. This is your output speeds here. This is the U-joint trying to speed up and slow down. And they do, but they get canceled, and it causes no speed up or speed down of the drive shaft in the end. So combination of phase and the angles kept within a good range prevents the vibration. So this is a picture of phasing here. You'll notice that this is a slip yoke here, but normally they'll master spline that. So basically what that means is they'll put two solid grooves in it, and the other one will have two grooves. So it can only go on in one direction, and that top picture is in phase, and our bottom picture would be out of phase. So that could happen if this had a master spline. I've never ever seen that it isn't. So for the most part, being in phase is not a thing we need to worry about. We just need to understand that it has to happen. And again, too, if you're building a drive shaft for a hot rod or you're changing something, you need to be cognizant of changing the driveline length and where those yoke lugs or the ends of the ears of the drive shaft need to be lined up in line. So there's the master splines comment there. So phasing angle video, that's the video I spoke to. Make sure you get on there, watch that video. I tried to build one in the shop, but just couldn't match what this video does at all. And it matches closely to the video I was educated with through to General Motors. Okay, so that's drive shafts. Rear-wheel drive vehicle, for the most part, has those parts we just spoke to. Now, half shafts, axle assemblies, or CV joints, or front-wheel drives, have what we call constant velocity joints. So there's no variable velocity. They will spin at the same speed at all times. So one thing they do is they eliminate velocity changes. They still allow torque transfer, same as a U-joint, but it can do it at 40 degrees. So that's where our front-wheel drives came in. Much better in the snow, much safer. So the old school people are pretty much done. They at first would prefer, I don't want a front-wheel drive. So getting that, building or designing a constant velocity joint allowed us to get those front wheels to turn at 40 degrees, which gives us a very respectable turning radius for cars. And so that was a big advancement in that. I kind of want to go back a step there. Pictures should show up there, but maybe a little later. Okay, and then the other one type of CV joint is called the fixed joint. And the fixed joint does not allow for a change in length. It will be your outboard or towards the wheel bearing. A double cardan is a double U-joint, so close together they consider it constant velocity. It's still a matter of they cancel out each other, but because it's such short. And a Zeppa joint is the name for most common fixed joint. And that's the fixed joint that allows for that 40 degrees. The other joint we'll speak to after. There's a picture of a double cardan. And there's a picture of a Zeppa. So they're both the outer joints there. That's where the axle nut would go on, and this would spline onto the wheel bearing. to transfer the power.